Hello everyone. In today's class, we'll be solving simultaneous equation using elimination method. Okay, using elimination method to solve our simultaneous equation. So how do we do that? Solution. Okay. So we are given three sets of simultaneous equation involving three variables. We have x, we have y, we have z. Okay, and we are giving, let's say this one is equation 1, this is equation 2, and this is equation 3. And we are using elimination methods to resolve these, but we are to determine the value of x, y, and z. So how do we go about this? Okay, solution. So let us start with, when we have three sets of linear equations like this, what we do is we can combine two equations at the same time. So let us say equation 1 and equation 2. Let's work with that first. So we have here x plus 2y minus z equals to 4. This is equation 1. Equation 2 is 2x minus 3y plus 2z, okay, equals minus 3. So let us solve this simultaneously using elimination method. And what do? Let us, when we have x, y, and z. So let's focus on y. When we look at the coefficient of y, we discover that it's different. We have this to be 2, this to be 3. So what we do now is we have to make it to be equal. And how we make it to be equal, we look for the least multiples of 2 and 3, which is our 6. That is our LCM of 2 and 3. That is the least multiple. And we make sure that this is 6, this one is 6. So to make this to be 6, we have to multiply everything we have here with 3, okay, times 3. And to make this to be 6, we have to multiply everything we have here by 2. Okay, so how do we do that? 3 times 3x is 3x, plus 3 times 2y is 6y, minus 3 times z is 3z, equals 3 times 4, I have to be 12. So for 2, you have 2 times 2x is 4x, minus 2 times 3y is 6y, plus 2 times 2z is 4z, equals 2 times minus 3 is minus 6. So from here now, I will have to subtract, I have to add this equation to this equation. This is minus, so I have to add. So plus and minus is minus, so this can easily go and turns to 0. So 3x plus 4x is 7x, okay? So I have here minus 3z plus 4x, okay? So I have this to be plus z equals, so this one is 12 minus 6, I have to be 6. So here I have 7x plus z equals 6, okay? So this is the result from resolving equation 1 and equation 2. We have this. So let me write this as 7x plus z equals 6. So the next thing is to, what do we do with the third equation? So we can pair this third equation with any of the two equations, either equation 1 or equation 2, we still have the same result. So where we have 3x plus y plus z equals to 7, this is equation 3. So for equation 1, I have x plus 2y minus z equals 4. Okay, so I can easily eliminate one variable. So I have here z, I have minus z, so I can easily take this out. Okay, so when I take this out, I'll be having, when I subtract this, when I add this to this, I have here 4x, okay, this plus 6y, so this is out, so equals 7 plus 4, I have to be 11. Okay, so since I've gotten this, I can now combine this with this. Okay, I have 4x plus 6y equals 11. So I'll solve simultaneously again, I'll solve further. So how do I do that? I have to, let us start with this 4x plus 6y, but in my previous equation, my previous answer here, I have x and z. Okay, so I have to work with x and z as well. So from here now, I have to work with x and z. That means I have to eliminate y. And how do I do that? I have to make sure that the coefficient of y here and y, they are equal. So since this one is 2y, so this will be 2y. And how do I do that? I will multiply everything by 2. So if I do that, I have 2 times 3x is 6x plus 2 times y is 2y plus 2 times z is 2z equals 2 times 7, I have to be 14, which is this. So for this I have x plus 2y, okay, minus z equals 4. So here I can now subtract this from this. So 6x minus x is 5x, okay. So this one is minus, that's not to minus, this one is 0. So this one is minus, that's not to plus. So I have 2z plus z now is 3z equals, I subtract this from here, I have 10. Okay, so for 5x plus 3z equals 10. Okay, which is this? I can now combine it with this first one, which is 7x plus z equals to 6. Okay, I'm doing this to determine the value of x. Okay, so from here now you solve further. So what do? We want to make the coefficient of z to be equal. So what do? We multiply equation 2 by 3. So when we do that, we repeat what we have here. We have 5x plus 3z equals to 10, which is this. And this, we have 3 times 7 is 21x, okay, plus 3 times z is 3z equals 3 times 6 is 18, okay. So by the time we subtract this from here, we have minus 16x, this one is minus, is 0, equals, when we subtract this, we have minus 8. So determine x, we divide by coefficient of x, which is minus 16. So this one is out, this one is out. So we have just x equals 8 here, 8 is 16, I have to be 1 over 2. So since I've determined 1 over 2 as x, I can easily come back to any of the equation here to determine z. Okay, so let me go with second equation. So I have to substitute, okay, x equals 1 over 2 in this equation, okay, which is this. So let me go with this. I have 7x plus z equals to 6, and for x to be 1 to be half, I have it to be 7 into half, okay, plus z equals to 6. So when I resolve this, I have this to be 7 over 2, okay, plus z equals to 6. So I can easily look for the LCM and resolve this. So when I resolve this, I have this to be 7, okay, plus 2z equals 12, okay. So I can easily determine z by dividing both sides by comparing the collecting like times. So when I collect like times, I have 2z equals 12 minus 7, which is 5 over 2. So if x is 1 over 2, okay, x is 1 over 2, okay, the value of my z, okay, is 5 over 2, okay. So the next thing for me is to determine y. So to get y, I come back to any of these 3 original equations, I substitute the value of x and z, I can easily determine y. So how will I do that? So let me use this first equation. So I have x plus 2y minus z equals to 4, okay. So for x is 1 over 2, okay, plus 2 times my y is not given, so I have to determine that is 2y minus my z, which is 5 over 2, equals 4. So here it states as saying 1 over 2 plus 2y over 1 minus 5 over 2 equals 4. So when you look for the LCM and you solve this, you have this to be 1, okay, plus 2 times 2y, okay, minus 5 equals 8. So here you have 1 plus 2 times 2y is 4y, minus 5 equals 8, okay. So when you collect like times, you have 4y equals 8, 1 minus 5 is minus 4. When it comes in, it turns to plus 4. I have it to be 12. So 4y equals 12. So that means the value of my y equals When you divide both sides by 4, you have y to be 3. Okay? So when you substitute this value back to any of this equation, it was given any of these answers. Okay? So when I put x, let me use equation 3 to determine my 7. So let me say check. Okay? If I say check, so here I have 3x plus y plus z equals, so for my 3x I have 3 times my x is 1 over 2, okay, plus my y is 3 and my z is 5 over 2. So when I solve this, I have 3 over 2 plus 3 plus 5 over 2. Okay, this is over 1. So when you solve this using the LCM method, you have this to be, this is 2, okay? So this gives you 3, okay? Plus this one is 6, okay? Plus this one is 5. So when we add up this together, we'll be having 3 plus 6 is 9. 9 plus 5, I have it to be 14. Okay, I have it to be 14. 14 divided by 2, I have it to be 7. So using elimination methods to handle variables involving 3 variables x, y, z, we got x to be 1 over 2, y to be 3, z to be 5 over 2. Thank you very much.